metrology usually carries two popular misconceptions. The first being that it is a form of meteorology, the study and prediction of weather, and the other being that it is something new. Either way, nothing could be further from the truth. Metrology is best defined as the science of weight and measure. That means metrology is as old as civilization itself. From the beginning of trade in the open market, metrology has been an integral part of everyday life. The metrology field may be thousands of years old. However, it's anything but static. From the ephah, cubit, and hin, measurement units from biblical times, to the English and metric units in use today, the metrology journey has been a long and dynamic one. Advancements in technology have always required metrology to keep pace, and vice versa. The advancements of the last 20 years alone have been staggering, and there's no end in sight. At one time, measurements were haphazard. Standards were different from one area of the country for length, weight, and volume. A yard in New York wasn't necessarily the same as a yard in California. How could you guarantee that what you bought in one area was the same as in another? You couldn't. The problems were the same for industry as well. Trades between the states were cumbersome. That's why in 1901, Congress founded the National Bureau of Standards. Today, it's known as NIST, the National Institute of Standards and Technology. One of the things that NIST is responsible for is making sure that all measuring standards are, well, standard. Here's what they do. Through a comparison process, NIST established all the units of measurement, starting with the 7 fundamental units: mass, the slug in kilogram; length, the foot in meter; temperature, Fahrenheit and Celsius; electric current, the ampere; light intensity, the candela; molecular substance, the mole; and time, seconds. The first 3 units are different in English and metric, the rest are universal. As science and technology progressed, NIST established new units based on the 7 original units, and then kept them standardized. The gallon, for example, is a unit for volume, which is a length times a length times a length. Or pressure is pounds per square inch. An increase in trade between countries also necessitated a development of international standards, and these standards have evolved over time. For example, at one time the international standard for the meter was a metal rod maintained in France. Today, the meter is defined by the wavelength of a particular light. This standard can be reproduced anywhere on Earth. So what is metrology? Everybody uses it, they just don't know it. Metrology is the scientific study of measurement and measurement procedures. What metrology isn't about is telling you what the weather is going to be like tomorrow. Don't confuse metrology with meteorology or metallurgy. All are sciences, but from there on they're quite different. The science of metrology is divided into 3 primary areas: physical, chemical, and electrical. Physical measures anything of a physical quantity: mass, length, weight, area, volume, anything that can be physically quantified. Chemical measures properties such as pH or molecular substance. And electrical metrology measures amperes, wavelengths, voltage, and items related to time and frequency.
My name is David Schiebel. I'm an Associate Professor of Metrology and Electronics at Butler County Community College. Our program's been in existence since 1981, and it is a comprehensive metrology program in the fact that it is comprised of chemistry, electrical, and dimensional metrology. My first experience with metrology was actually on the job. I was working for a company that got themselves into trouble essentially by not paying close attention to the metrology needs. They ended up over time producing products that didn't meet their own specifications, and the customers were literally sending all these products back. So we kind of had to go in as more or less a cleanup detail and right the situation, get everything in the company calibrated back to standard measures, and get things straightened out for them. Metrology applies to everyday life because it's an integral part of the development of any product. From the design stage, the research and development, the engineering, and the quality control that goes on in actually manufacturing that product. Metrology is an integral part of it all the way.
Where you probably most often run into the science of metrology are tape measures, speedometers, the gasoline you put into your car, or any foods that you can purchase by weight or volume. Metrology has been used to measure out all those things and to set certain measurement standards. This is called physical metrology because it deals with tangible items that you can quantify or observe. But the science of physical metrology is actually much more sophisticated than that. Everything relates back to the standards of mass, time, and length. The challenge is to make sure that every tape measure, or every gas pump, measures uniformly, and that the various units of measure are referenced correctly to each other. Scientists in the physical metrology field are responsible for calibrating measurement equipment and making sure that all that calibration equipment is tested and traceable back to national standards. Others may work in a quality control environment where precision measurements are critical.
Hello, my name is Gabriel Robb. I'm the quality manager at Cygnus Manufacturing Company, also known as CMC, in Saxonburg, Pennsylvania. Metrology is important to this company because our customers are constantly pushing our limits when it comes to machining tolerances that they want us to hold. Tolerances are getting smaller and smaller all the time, and because of that, we have to be able to refine our measuring process in order to determine whether or not we've met those tolerances. Back in the old days, they used to build locomotives, and if they could fit a nickel between the cylinder wall and the piston, that was considered a tight tolerance. Nowadays, you're talking millionths of an inch sometimes. We have parts out here that we have to hold tolerances of plus or minus 50 millionths of an inch. If you held the part in your hand, you could actually watch it grow with your measuring inspection equipment. So we have to be able to determine what influences our measurements, what kind of errors can we anticipate, and factor those out of our measurement system. Some of the unique qualities about BC3's metrology program that might attract new students into it, a good draw to them, is the diversity of the program. It's just not focused on one aspect of metrology. You got chemical analysis, you have optics measurements, you have physical measurements, electrical measurements. So it gives the student an opportunity to pursue his strong interest in any one of those fields. My goal in graduating high school is really to get into mechanical engineering. I never did pursue that, but metrology, because it was a science and it used some of the skills and the interest that I had, I was very attracted to it. On the same level, I was also interested in an employment that would pay well and had good job placement. Through the metrology program itself, I found out had good job placement and paid decent salaries to start off with. It was a 2-year program. I could get through it very quickly versus a 4-year program at a university. And I felt that I was going to get the same benefits out of it.